The complex number z is given by z is equals to cosine of 1/16th of a pi plus I sine 1/16th of a pi, and the whole thing is squared, and divided by or over cosine 1/8 of a pi minus I sine 1/8 of a pi. So the question says find the modulus of z as well as the argument of z. So and then after you've done that, hence find the value of the square of z. Okay, so that will be for 3 marks. So let's look at how we can do that. So the first thing we're going to do is to express the given z in exponential form. Okay, so what would be the numerator? So for the numerator, as we can see, the argument is 1/16th of a pi. So we can express this cosine pi over 16 plus I sine pi over 16. Okay, it's got a modulus of 1, and therefore the number in front of the e is a 1, so which I didn't write, of course. So then the argument is pi over 16. So when you express the numerator, okay, in terms of an exponential, its exponential function, it will be e to the power of I times pi over 16. Pi over 16 is the argument. Now let's do the same thing with the denominator. So this also has a modulus of 1. So that means the magnitude of this is also 1. And the argument is pi over 8. So this, of course, could be expressed because this is a minus. So what we can do is we can convert this into the argument into a negative angle. So cosine minus pi over 8 is basically the 4th quadrant angle, so in which cosine is actually positive. So cosine pi over 8 is the same as cosine of negative pi over 8. So I have converted it into a negative angle, and of course we know 4th quadrant of a negative angle, negative pi over 8, is the same as minus I sine pi over 8. So we could change the argument in terms of the negative angle. Okay, so what would be the value of this is, of course, going to be e to the power of I times negative pi over 8. Okay, so because of the minus sign, so we have to convert it, the argument, into the 4th quadrant angle, which is negative pi over 8. So we have the numerator and the denominator expressed in terms of its exponential forms. So now let's work out what is z. Okay, z is this value, and of course there's a square sign, we shouldn't forget that. So e to the power of, the numerator when expressed in exponential form, it was e to the power of I times pi over 16, and of course since it has a square, so I have put in the square there, and then we're going to divide that by this the denominator. So denominator is e to the power of I times minus pi over 8. So of course first thing we're going to expand this bracket. So pi over 16, if we times by 2, it's going to become pi over 8. So it's going to be simply e to the power of I times pi over 16 times 2, which is pi over 8, because 2 and 16 can cancel to give you the 8. And then for the denominator, I'm not going to do anything, so I'm just going to keep it like that. Now we can apply the rule of indices. Since the bases are the same, we can subtract the powers. So e to the power of I times pi over 8 minus I minus pi over 8. So it's going to be simply pi over 8 minus pi over 8. So which is going to look like this. So I have just subtracted the power by rule of indices of subtraction of the powers. So now we can simplify. The minus and the minus would turn it into a plus. So we've got a pi over 8 plus another pi over 8 of the I. So which is going to become simply pi over 4. So pi over 8 minus is going to become plus pi over 8, and that would turn it into a pi over 4. So this entire complex number, if you write it in exponential form, it is simply going to be e I to the power of pi over 2. And as we can see, the argument of this complex number z is pi over 4. And the magnitude or the modulus of z is going to be just simply a 1. So as a question asks, this is equals to e I pi over 4. So what will be the modulus of this number? Of course, the modulus of this is simply a 1, because in front of I there is no coefficient, so modulus is 1, and the argument of z is simply pi over 4. So there we have the first part, modulus of z and the argument of z. But we are told, hence find the value of the square of z. So what would be z squared? So this is my z in exponential form, e to the power of I pi over 4, and all we are going to do is to square it. So of course when you square it, we can multiply the powers together. So the 2 and the 4 we could cancel and turn this into a pi over 2. It is simply going to become e to the power of I pi over 2. And of course if you change it back into its rectangular form or trigonometric form, so it will be cosine, the real part would be cosine of pi over 2 plus I sine pi over 2, and cosine pi over 2 is cosine 90 degrees. Cosine of 90 degrees should of course be 0, and sine pi over 2 is 1, so 1 times I. So therefore your z squared would simply become I. So it's just a square root of minus 1. That's the value of the square of z. Let's now look at part 2. The part 2 says part 1 says, show that cos theta plus I sin theta plus 1 plus cos theta minus I sin theta is equals to 1 plus cos theta plus I sin theta. So let us look at how to convert this into exponential form and then proof, right? So cosine theta plus I sin theta, if you express it in exponential form, it is simply going to be e to the power of I times the theta, because this also doesn't have any coefficient in front, so the magnitude is 1, and the argument for this complex number in this first bracket is simply theta, so I just put it as I times theta. Now let's look at the second bracket. So the second bracket says cos theta minus I sin theta. I'm just going to concentrate on this part first. Of course, cos theta minus I sin theta, when you have a minus sign, of course we can throw the minus sign into the theta. So cosine negative theta is the same as cosine theta, right? So we can change this into a cosine theta, cosine minus theta plus I sine of minus theta, because if I throw minus sine theta, sine minus theta is the same as minus sine theta. So from this we can readily see that the argument is negative theta. So and the modulus is still 1. So for this part it is simply e to the power of I times negative theta. So that is only this part of the bracket, which is cos theta minus I sin theta, which I have converted it into exponential form. Now we are told to take cos theta plus I sin theta multiply by 1 plus cos theta minus I sin theta. So whatever that we express in terms of exponential form, let us substitute that. So the first bracket I'm going to replace it with e to the power of I theta, right? So because that is what it is. And here we have a 1 plus, so I write the 1 plus, and cos theta minus I sin theta, which we have already also expressed in exponential form as e to the power of I times minus theta. So there we have it. And then the next step to do is to expand these brackets. So 1 times e to the power of I theta will simply be e to the power of I theta, and this is a plus and a plus, and of course e to the power of I theta times e to the power of I minus theta. By rule of indices we can add up the powers together, so it's simply I've just copied down here without simplifying. So e to the power of I theta multiplied by this. So now the next step is, of course, we can add up the two powers together, e to the power of I theta plus minus I theta, which is of course going to be reduced to become e to the power of 0. So I theta minus I theta is going to become 0. So anything to the power 0 is of course a 1. So it is 1 plus e I theta plus a 1. So that's what we have, or that's what it simplifies. The left hand side simplifies into. And what is e I theta if you change it back into exponential form? If you change it back to rectangular form, so it would be cosine theta plus I times sine theta, and of course there is no number in front, so the magnitude is a 1, and we have a plus 1, and this is what we needed to show, okay, to the right hand side, and there we have shown it. Now let us look at how we can show hence or otherwise find the value of, okay, 1 plus z to the power of 4 plus 1 plus the conjugate of z to the power of 4. So from the first part, okay, we have already shown, okay, this is equal to this, so therefore we can make use of this result, okay, to do the subsequent parts, right? So let us substitute theta is equals to pi over 4. So when theta is equals to pi over 4, what does it become? So this is going to become cos pi over 4 plus I sine pi over 4, okay, and then we multiply this by 1 plus cosine, of course, since we are putting in the theta as pi over 4, so we get a cos pi over 4 minus I sine pi over 4, right? And if I were to do that same thing on the right hand side, it's going to become cos pi over 4 plus I sine pi over 4 plus 1. So if you change this into exponential form, this is going to be e I pi over 4 because the argument is pi over 4. This part here is 1 plus, okay, this, if you recall, okay, we could change the minus by changing it into minus pi over 4 and minus pi over 4. So this simply is going to become e to the power of I times minus pi over 4. Okay, it is very similar to what we did for the earlier part. Okay, and this should be equals to, if I were to change this, okay, also into exponential form, this is e to the power of pi over 4, okay, so plus a 1. So I wrote the 1 in the front and this part e to the power of I times pi over 4 at the back. So that's what we have. Now let z be called e to the power of I over 4. So this is the z, okay. If I consider this as my z, e to the power of I pi over 4, so what would this entire thing now become? Okay, so this is a z. This is going to be 1 plus e to the power of I times minus pi over 4 is basically, since the angle has become negative or the argument has become negative, it is actually the conjugate of the z, right? Conjugate of z, okay, z's argument, if it is pi over 4, their conjugate will be the reflection about the real axis, so which is going to be minus pi over 4. So this is your conjugate of z, and then if you go to the right hand side, so this is 1 plus, okay, this is basically z. So we have z times 1 plus conjugate of z is equals to 1 plus z. Now let's increase, let's add a power 4 to each and every one of the term here. Z to the power of 4, of course I will have to raise this to a power of 4. 1 plus conjugate of z to the power of 4 should be equal to 1 plus z to the power of 4. So what we need to have is 1 plus z to the power of 4 plus 1 plus conjugate of z to the power of 4. So how do we do that? So what is z to the power of 4? Of course, if I take this, okay, and I power it to 4, so it's going to be e to the power of pi over 4 times 4. The 4 and 4 will cancel, and that's going to just simply leave you with a pi. So it would be e to the power of I times a pi. And what is e to the power of I times pi? When the argument becomes a pi, so what is that is actually equals to? Z to the power of 4 is equals to simply negative 1, because cosine pi is going to be negative 1, sine pi is going to be a 0, so there is not going to be any imaginary component, there is going to be only real component, okay, which is minus 1. So we're going to replace the z4 with just simply, it's a real number, so it's minus 1. So if I were to just replace it with a minus 1, so this is simply going to become minus 1 plus conjugate of z to the power of 4 is equals to 1 plus z to the power of 4. So we have it, and of course I'm quite sure that you can see what is going to be the logically the next step. Okay, throw this over to the right hand side and you would have actually found out what is the value. So I have the 1 plus z to the power of 4. This part is minus, so if I throw it over to the other side, it's going to become 1 plus z to the z bar to the power of 4, or conjugate of z to the power of 4, right? And since I have already brought it over, so what would be the left hand side equals to? of course the left hand side would simply become 0. So this is the value of 1 plus z to the power of 4 plus 1 plus conjugate of z to the power of 4. So when you have done that, you would have gotten another 2 marks.